We are now talking about complex numbers. Now, the first thing we should be understand are the types of numbers. What are the types of numbers which we have? We had already mentioned this. The biggest set of numbers is a set of complex numbers. Now, if we say a complex number, what do we mean? A complex number is a number that is not real. Okay, that is not real. We are going to understand. So, in the set of complex numbers, we are going to find real numbers, meaning that the set of real numbers is a subset of the set of complex numbers. In the set of real numbers, we also find different types of numbers. So just in the set of real numbers, we'll be able to see integers. Okay, integers. Now, real numbers are all numbers from negative infinity to positive infinity. Any number that you can think of in your mind is a real number. 0.5, 1, 2, 0, -20, square root of 5, square root of 2, everything. Every number you can think of in your mind is a real number. Set of integers are positive and negative numbers. It's also from negative infinity to positive infinity. But the only difference is this. For integers, you don't include decimals, you don't include improper fractions, you don't include mixed fractions. Only whole numbers. -5, -6, -7, 0, 1, 2, 3, 4, like that. Those are integers. Okay. In the set of integers, you can also find whole numbers. So all numbers are just numbers from 0 all the way up to infinity. And you don't include decimals. So just 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you continue like that. In the set of whole numbers, you can also find natural numbers. What are natural numbers? Natural numbers are basically whole numbers, but you don't include 0. So start from 1, you continue counting like that. Okay. So those are natural numbers. You will see the symbols for natural numbers is N. For whole numbers, I have not even seen the symbol they use. Integers, here we are going to use a Z like that. Real numbers will use R like that. Complex numbers, we can just know them like that, but sometimes you can see like others might use a Q or something. Okay. Now, when it comes to real numbers, just the same real numbers, in the set of real numbers, we can also have two special numbers, which we have already talked about and we have understood them. So these two numbers are rational numbers and also irrational numbers. So they are part of the real numbers. Again, when you go to the set of integers, the set of integers can also give us odd numbers, even numbers, and also prime numbers. Odd numbers, these are numbers like 1, 3, 5, 7. We're always keeping a number like that. Even numbers, just the direct opposite, 0, 2, 4, 6. You continue to go like that. Prime numbers, these are numbers that you can only divide by 1 and themselves. For example, a 2, a 3, a 5, a 7, 11, and you continue to go like that. Those are prime numbers. So basically, these are the numbers that you come across. And I saw one question which just gave different numbers. They said, from the four given numbers, write a set, whether they are real numbers. I'll give you that for a question so that you can work with it. Now, to go into detail, talking about complex numbers, it all started with this question. If they've given you a question like x squared minus 4 is equal to 0, they ask that find the value of x. Normally, what you do is you are going to get 4 and take it the other side. So it becomes x squared is equal to 4. At this point, for you to be able to get the value of x, you need to square root both sides. So it becomes square root of x squared is equal to square root of 4. The square root and the square cancel, so that gives you x. But you need to know that every time you square root something, the answer can either be positive or negative, meaning that the answer is going to be positive square root of 4 or negative square root of 4. Now, can you tell me what number can you multiply 2 times by itself for you to get a 4? Say 2. Okay, very good. So here it is going to be positive 2, or here also it will be a 2. But remember, we are multiplying with a negative that is outside. So it will give us a, or x is equal to negative 2. So we get these two values. But then, imagine the question they gave was x squared plus 4 is equal to 0. You want to solve this equation. You need to do the same thing. Take the 4 the other side, it will become negative 4. To find the value of x, you still square root both sides. But remember, the answer can either be positive or negative. So this gives you that x is equal to positive square root of negative 4, or x is equal to negative square root of negative 4. Now, can anyone tell me what number can I multiply by itself 2 times so that I get negative 4? Anyone? What number can I multiply by itself 2 times so that I get negative 4? Are you thinking of any number? It's not the same number. You've used two different numbers. So we want the same number that we can multiply twice. It's not the same number. So every time you're finding square root, finding the same number you can multiply by itself twice. So negative 2 and 2, those are two different numbers. So you cannot find the square root of a negative number. Okay? You can't find. So what do you do in that case? What you do is you say, I've already taught you sides. Okay, so x is going to be equal to, so for me to find the square root of negative 4, I've already told you sides. Square root of negative 4 is the same as 4 multiplied by negative 1. And we already did with this. When you're multiplying two numbers inside the root, it means that they were actually separate. It was square root of 4 times the square root of negative 1. Square root of 4 is a 2. Square root of negative 1 is called I. Okay. So meaning that x is equal to positive square root of 4 is going to give us a positive 2i, or x is equal to negative square root of 4 is going to give us negative 2i. So every time you see I, that is a complex number. Okay? That is a complex number. Yes, Martin? Can you say that again? Mm-hmm. So I said when you square root a number, two numbers that you can get, a number that you can use to find that same number in the root. But I've not removed this in a root, it's still in the root. So it's different if I say square root of 4 is equal to 4 times 1. This is not the same. That one is in the root. Okay. So that is the basis of complex numbers. So one of the quizzes they gave me when I was in first year, quiz one, came define a complex number. So what they brought is for one group they brought for them to say define a rational number. For another group they gave them define an irrational number. For another group define a complex number. So a complex number is a number that is in the form a plus ib, or you can say a plus bi. Now the numbers a and b, these two guys are real numbers, okay, and then I is the imaginary number. Imaginary number, it's not real. That's why we say these are complex numbers, because they are not real. So for example, I can say z is equal to 2 plus let's say 3i. When you are using numbers, the number is going to be in front mostly and always. But when you are using letters, the I is going to be in front. But there's no if you put the I behind. But when you are using numbers, you can't write I3. No, 3I. When you're using letters, it doesn't matter which one starts. Okay, so this is a complex number. Now, sometimes if this b is a 0, that complex number is going to become a real number. Think of it. For example, 0 times I is 0. So meaning that z is just going to be equal to a. Okay? Z is going to be equal to a. And a alone, we have said, is a real number. So meaning that that complex number becomes a real number. What does that mean? Meaning that all real numbers are complex numbers. Okay, all real numbers are complex numbers. That's what we said. We said a real number is a subset of a complex number. All numbers come from complex numbers, meaning that a real number is also a complex number. But not all complex numbers are real numbers. So that's the difference. Now, just like we can represent real numbers on a Cartesian plane, we can represent complex numbers on an Argand diagram. Hope this is the spelling. Argand diagram. Now, an Argand diagram is more like the X or Y plane. Okay, it's basically the same. The only difference is that this value of A is the X value, so that is 2. The number that has got I, this is known as the imaginary axis, and then this is the real axis. So the number that has got the I will be on the imaginary axis. You don't include the I. Just by a number being on that axis means that it has got the I. So this will be the coordinate. Okay, that is going to be the coordinate. You can actually connect this starting from the origin like that. So because of that, you can see there is an angle here. Okay, so you can actually determine this angle here, theta, and this angle is known as the argument. They can ask you to find the argument. Calculating the argument is the same as we did in vectors. Okay, so this is, you can think of it as the y value. This here is the x value, and we said tan of theta is given by y value over x value. So meaning that tan of theta is going to be, the y value is always that number that has got the I. So just get the number in front of the I. The x value is the number without the I. So to remain with theta, I'll take tan the other side, so it becomes tan inverse of 3 over 2. So that is how you are going to be able to determine the argument of a complex number there. Any question? Did you attend the vectors? So you use SOHCAHTOA. SOHCAHTOA. Tan of an angle is given by the opposite side divided by, this is the opposite side divided by the adjacent side. So this is the angle, the opposite side is this one. Adjacent means next. So what is next to it is this side. Because this one is the longest side, is hypotenuse. So tan is going to be opposite of hypotenuse. So the opposite is y, the hypotenuse is x, which is there. So tan theta becomes y over x because it was supposed to be tan theta is equal to opposite over adjacent. And y, we have said the y value is this one, which is the imaginary number, over x, which is 2. To remain with the angle theta itself, you take theta, tan the other side. It's not taking, I'm just using a language for you to understand. You take tan the other side, so remain with theta. But if you take tan the other side, it becomes tan inverse, 3 over 2. Okay. If you punch this on a calculator, you're going to find the angle. Is that okay? Okay. So this is actually going to be 56.3 degrees. So that's the angle there. Okay. Mm-hmm. No, you don't use the calculator. So you just end here. But don't worry, I'll teach you trigonometry. You can actually, numbers that they'll give you in mathematics are numbers that you can deal with without a calculator, known as spatial angles. We'll deal with all those when we do trig. Okay. Now there is something very special you need to understand. And if you miss this one, trust me, I remember they brought what is I to the power 200. Okay. So you need to know. Okay. Remember we have said the square root of negative 1. Teresa or Teresa. What is the square root of negative 1? What is the answer? Square root of negative 1. Mm-hmm. Okay. Yes, Amon. Okay. Uh, Wilfred. Wilfred, you can go on. Negative 1i. Okay, thank you. Kelvin. Okay, just an I, you guys. I. Wh- Why have you forgotten? Here, here, here. Hmm? We said square root of 4 is a 2. Square root of negative 1 is I, so that gives us 2i. Square root of 4, negative 1 is I. So what is I? I is equal to, what is I? Ah, what is I? Square root of negative. Oh, you guys. Okay. Yes. Square root of negative 1. Okay. Okay. Now, let me square both sides. Let me square both sides. What I'm going to do is I'm going to square here, I'll also square here. What am I going to get? What am I going to get? No one is speaking. If I square both sides, what am I going to get? You people don't complicate things. It's what you are thinking about is the answer. Hmm. So I squared is equal to negative 1, you people. Yes. Uh-huh. There's no square root here. I've just squared. I've just squared both sides. There's no square root. Okay. So you've seen what will happen? The square root and the square will cancel. Okay. So have we gotten this? It's okay now? Very good. Very good. Please, this is all I want. From here, things will be becoming beautiful. So make sure that you understand that. So we are saying that I squared is equal to what? What is I squared? Very good. Okay. Negative 1. Very good. Okay. Now, if I multiply both sides by I, imagine I multiply on the left by I multiply this side by I, also this side by I. Tell me what are we going to get? Alright. Okay, so I times I to the power 2, not cube root, but cube. It becomes I to the power 3. And then negative 1 times I will be negative I. Is this confusing? This is a simple multiplication. 8, 8 times a squared is 8 to the power 3. You've gotten now, huh? Okay, A times A times A. Okay. Hmm. So, I to the power 3 is the same as negative I. Does this make sense? You get, huh? S- s- Okay. So I'm doing this so that you understand where things will come from because I'm about to. This one, trust me, they will not teach you. They will not trust me, they will not. But they will give you to say what is I to the power 200. They want you to find, but then they will not teach you. They'll just give you basics. So I'm doing this so that you get to understand. Okay. Now again, I'm going to multiply this one by I, and then I also multiply this side by I. What are we going to get? I times I to the power 3 will be what? Very good. Very good. Okay. I to the power 4 is equal to negative. Very good. Okay. So now we are getting things. Huh? But where there is I squared here, I'm going to replace with the negative 1. So what are we going to have? What are we going to have? Very good, Harry. Okay. We are going to have a positive 1. Positive 1. We get that? Huh? Okay. So I to the power 4 is actually a positive 1. This one again, I'm going to multiply. Let me multiply this side by I. This side I also multiply by I. What are we going to have? Mhm. Positive I. Very good. Okay. So it's just 1 times I. That is I, isn't it? No, 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 no. So negative 1 is I squared, isn't it? Okay. So Mr. John, is it clear now? Okay, very good. I'll multiply again by I this side. I'll also multiply by I this side. What are we going to have? Uh-huh. I to the power 2. But what is I to the power 2? Negative 1, right? So where there is I to the power 2, I'm going to put negative 1. Okay? Negative 1 there. All right. So let me multiply again. Let's multiply this side by I, this side by I. What are we going to have? Uh-huh. Negative I. Very good. Okay. And then now tell me without me writing. If I multiply again by an I both sides, what are we going to get? Negative I squared, isn't it? But where there is I squared, we replace what? A negative 1. So what are we going to get? positive 1, isn't it? It was like, yes, there have been two negatives. Remember, I squared is negative 1. So where there's I squared, that's where we're putting negative 1. Do you get this? No, 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 no. It's not negative 1 to the power 2. Where there's I squared, we are replacing negative 1. So it is negative 1. Where there is I squared, that's where you're putting negative 1, not negative 1 squared. Okay. Kelvin's mic is on and we are hearing things in the background. Okay. And then if I multiply by I this side and by I this side, what are we going to have? What are we going to have here? Very good. I to the power 9 is equal to I. Let me do it one more time. If I multiply by I this side and then I multiply by I this side, what are we going to have? Which is a negative 1. Good. Do we have any questions up to here? Any questions? Michael? Yes? Okay. Yes. But unfortunately, if you've not registered, you not access it because I'll just send it on email. I'm not sending it to the groups. Oh, good. So you'll find it on your email. Okay. Now, Teresa, can you tell me how you pronounce your name? What's your name? That's Teresa. Oh, okay. 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 All right. So I hope you've gotten how we've been doing this together. So nshirefo kwisambepesha tiyo these things. No, I can't start again. This thing is long. Okay. So we multiplied I here. We also multiplied I here. I times I to the power 9 is I to the power 10. I times I is I squared. But remember, I squared, just the first one is negative 1. Okay, so now I want you to notice what is repeating. Let's start with what is giving us negative 1. Apart from I to the power 2, what else is giving us negative 1? I to the power 6, I to the power 10. Good. So this is going to be the same. Now you need to look at the general trend. From I to the power 2 for you to get to I to the power 6, what is happening to the power? What number are we adding to the power? Uh, for us to move from I to the power 2 to I to the power 6, what number are we adding to the power? By a 4, very good. How about from 6 to 10? It's by 4. So it is the same trend. So this means that I to the power 2, if I add a 4, now this 4 can be in multiples of n. It always give me a negative 1. For example, if n is 0, it will just be I to the power 2, that is negative 1. If n is a 1, it will be 2 to the power, I mean, it will be 4 times 1, right? Which is 4 plus 2, which is 6. So it becomes I to the power 6. And that is still a negative 1. If n is 2, 4 times 2 is 8. 8 plus 2 is 10. I to the power 10 is a negative 1. So if n is, let's say, 3, 4 times 3 is a 12. 12 plus 2 is a 14, meaning that I to the power 14 also give us a negative 1. If n is, let's say, 4, 4 times 4 is 16. 16 plus 2, 18. I to the power 18 also give us a negative 1. So that is a general trend. Is that okay? Very good. Okay. So let's go. Okay, you are going to get the concept on I to the power 3. Let's go to I to the power 3. I to the power 3 is giving us negative 1. Martin, okay, let's use this one. Make sure you understand. Okay, so let's go to what is giving us a negative 1. Apart from I to the power 3, what else is giving us a negative 1? I mean a negative I to the power 7. Okay. Also, I to the power 11. Had I multiplied by I here would have had I to the power 11 is equal to negative I. So what do you think? What is happening to the power 3 for us to get to the power 7? It's increasing by what? By 4. Okay. Yes. Okay. So we are actually adding a 4 also. So the general trend is when we have got I to the power 3, we add a 4, it is going to give us now this is not only 4 but anything in multiples of 4, so it's 4n. It always give us a negative I. If n is 0, it will be 4 times 0, which is 0, plus 3, which is 3. I to the power 3 is negative I. Our microphones can be off. If n is 1, 4 times 1 is going to be 4. 4 plus 3 is going to be 7. I to the power 7 is also a negative 1. If n is a 2, 4 times 2 is 8. 8 plus 3 is 11. 11 I to the power 11 is also a negative I. If n is 4, 4 times 4 is 16. 16 plus 3 is that a 19. So I to the power 19 should also be a negative I, and just like that. Is that okay, Martin? Okay, good. Okay, let's go to what is giving us a 1. Apart from I to the power 4, what else is giving us a 1? I to the power 8. Okay, another one, I've not just written it. Another one which will give us I to the power 12 will also give us a positive 1. Yes. So what is happening if I have got I to the power 4? What is happening for me to go to the next? For me to move from power 4 to power 8 to power 3 to power 12, I mean, what is happening? We're adding a 4, right? But this is true. But do you notice that it is the same as me just multiplying, just adding n, 4n? Look at this. If n is a 1, so if n is a 1, we are going to have I to the power 4, right? I'm using this one here. Are you able to see? If n is 1, what would be my power? 4, isn't it? If n is 2, what would be the power? 8. If n is 3, what would be the power? 12. You see, so for this one, is you can actually use both, and this will always give you a positive 1. Is this okay? Okay. Now, the last one. Let's go to the one which is giving us what's that? An I. So apart from I to the power 5, what else is giving us I to the power 9. Even I to the power 13 will give us I. So what is happening if we have got I to the power 5? What are we doing for us to reach to the power 9? Okay, adding a 4, and it will be in multiples of n, and this will always give us a positive I. Now, the thing, I don't want you to master this. I want you to know, because as you go on, you realize there is too much to master. So you will not manage. Okay. The last time I touched mathematics was some time back. I'm doing a program that is far away from mathematics. But then I'm not even using a book to teach you now, because I never mastered these things. Okay. I've never used a book. Every time I'm teaching you, I don't use a book. I formulate questions. So the thing is, know what is happening and you never forget. However many years pass. The last time I studied this, I think, was in 2021, something like that. So, okay, it's not okay. So let's do this now. Let's find what is I to the power 200. Okay, what is I to the power 200? We want to simplify it. We just want to give, if the answer is a negative 1, a negative I, a 1, or an I. Okay, so how do you find that? So to be able to find that, what you are going to do is, now first ask yourself, is this one an odd number or an even number? Even number. So I should go to those powers which are even. For example, this one is even. Also, this one is even. Okay, so I can't use this and this. You see. So if I can disqualify like that, it means I've already simplified a bit my work. So I'm going to say, okay, let me use this one. Let's say if I is equal I to the power 200, give me the same answer as I to the power 4n. Now please, this n is an integer. It should always be a whole number. Okay, a whole number. If I find n to be an integer, then that means that I to the power 200 can be expressed in that form. And definitely that it means that it should give me 1. And it will always only work for one of these four equations I've written here. So since the bases are the same, the power should also be the same. So I'll say 200 is equal to 4n. So let me divide over 4 over 4. Uh-huh. It's 50. So you've seen I found the whole number, right? So meaning that I to the power 200 is actually equal to a 1. And let's say if I tried this one, I say, okay, I to the power 200 is equal to I to the power 2 plus 4n, like that. Okay, since the bases are the same, I'll equate the powers. I say 200 is equal to 2 plus 4n. I'll take 2 this side, so it becomes 200 minus 2 is equal to 4n. That will give us 198 is equal to 4n. I divide both sides by 4. So what will be n? So it will actually be like a 49.5. Now, is this an integer? 49.5, is it an integer? It's not. I said integers are numbers which don't have decimals, they are not improper fractions. Counting numbers 1, 2, 3, 4, -1, -5, like that, not with a point. Okay, so meaning that at the power 200 is equal to 1. So you can try out this 1 to the power 150, what it is equal to, I to the power 500. You can try that at your own time. Okay, do you have any questions on this? It's here. Yes. It's okay. Teresa, you can answer that one. Pretending to understand. Good. Do we get this now? Should I give you time to make? There's no slide. I've removed it. Okay, so okay, I can ask you a specific question. So I answer you. We conclude. Anyone who wants to ask? Okay. Let me try to give you another example. Say you have got I to the power, let's say 275. Okay? We want to find what this is going to be equal to. The first question you need to ask yourself is 275 an odd number or an even number? So is it even or odd? It's an odd number. Just look at the number at the end. If it is not 246024688, those are odd numbers. So now come on these numbers here. Which ones are odd numbers? 3 and 5, okay? So you identifying the meaning that this number, the possibility is that it can be equal to -1 or it can be equal to I. Okay? Negative I or I. Now you need to test which one of these two it is going to work for. So try to say, let's try to use the first one. I to the power 275 is equal to I to the power 3 plus 4n. If we find n give and it gives us a whole number, then it means that I is going to be equal to I to the power 275 is going to be equal to -1. Do you get that? Okay, so let's find the value of n. So just equate the powers. 375 is equal to 3 plus 4n. Take 3 the other side, it will give you 3, 7, 370 what? And that is going to be equal to 4n. So divide 372 by a 4. And that is going to give us n being equal to a whole number, 93. So meaning that I to the power 275 is equal to what? -1. Now imagine you wanted to, okay, let's say if we try also the 5 plus 4n. So we're going to say 275 is equal to 5 plus 4n. Take the 5 the other side, that gives us 2 what? 270 is equal to 4n. Divide both sides by 4 to find the value of n. And it will give you 67.5. Is this an integer? It's not an integer, it's a decimal. Teresa, why are you thinking? I already mentioned this. Teresa. Okay. So that is how you determine. Hope this is okay. Yes, I'm on. Very